For 300,000 years, the human brain evolved to solve exactly one kind of problem: how to survive the next 24 hours in a small group in the wild with no backup plan. Then, in the blink of an evolutionary eye, we built cities, screens, currencies, and calendars. Nobody told your brain the rules had changed. It is still playing the old game in a world that stopped making sense to it a long time ago. And once you understand the mismatch, almost everything about modern life starts to look different. Let's start with a number, because the number is the whole story. Homo sapiens has existed for roughly 300,000 years. For about 290,000 of those years, every single human on Earth lived as a hunter-gatherer. Small bands, constant movement, food that had to be found, not bought. Agriculture, the first real departure from that lifestyle, arrived only around 12,000 years ago. Cities followed a few thousand years after that. Writing came later still. And the truly disorienting stuff, factories, electric light, cars, the internet, all of that is crammed into roughly the last 200 years. If you compress the entire history of Homo sapiens into a single 24-hour clock, agriculture wouldn't begin until about 11:57 p.m. The Industrial Revolution would start in the final half second before midnight. Your brain had 290,000 years to fine-tune itself for one specific environment. It has had almost no time at all to adjust to this one. In 1859, a French neurologist named Paul Broca examined ancient human skulls and compared them to modern ones. His conclusion, later confirmed repeatedly by generations of neuroscientists, was straightforward. The physical structure of the human brain has barely changed in tens of thousands of years. You are, biologically, walking around with hunter-gatherer hardware, and you are asking it to run software it was never designed to load. Here is where the mismatch gets specific and slightly unsettling. Your stress response, the fight-or-flight system that floods your body with adrenaline and cortisol, evolved to handle acute physical threats: a predator, a fall, a sudden attack. It was built to activate hard, resolve fast, and shut off completely once the danger passed. In 2004, researchers at UC San Francisco, led by Elisa Epel, studied women caring for chronically ill children, a situation involving sustained psychological stress rather than physical danger. What they found was striking. The women's cells showed measurable signs of accelerated aging. Specifically, their telomeres, the protective caps on the ends of chromosomes, were significantly shorter than expected for their age. Shortened telomeres are associated with a range of age-related diseases, and, on average, earlier death. Chronic stress was aging these women from the inside, cell by cell, and the mechanism responsible was a system built for sprinting away from danger, not for sitting with worry for months or years at a time. Right now, somewhere in your body, that same ancient alarm system fires in response to an overdue email, a tense meeting, a notification. Your amygdala cannot tell the difference between a predator in the grass and a passive-aggressive message from your boss. It reacts the same way to both. The threat has changed completely. The alarm system has not changed at all. Food tells the same story, just with a different chemical. For most of human history, sugar was rare, seasonal, and valuable. But ripe fruit or a wild honeycomb represented a genuine nutritional jackpot, a dense burst of calories worth working hard for. Your brain evolved a powerful reward response to sugar, because in that environment, craving it kept you alive. Then, within the span of a few generations, sugar became one of the cheapest, most available substances on the planet. In 2019, researcher Kevin Hall ran a controlled study at the National Institutes of Health, keeping participants in a metabolic ward for a month. For 2 weeks, they ate whole, unprocessed food. For 2 weeks, they ate ultra-processed food matched for calories, sugar, and fat. On the ultra-processed diet, without anyone changing portion sizes or telling them to eat more, participants consumed roughly 500 extra calories per day, automatically, without noticing. The same evolved craving that once protected a hunter-gatherer from starvation now works against someone standing in front of a supermarket shelf lined with hundreds of engineered sugar delivery systems disguised as breakfast cereal. Your desire for sugar is not a personal weakness. It is 300,000 years of programming meeting an environment engineered specifically to exploit it. Then there is attention, which might be the most dramatic mismatch of all. Your ancestors needed an attention system built for constant vigilance and rapid shifting. Notice a sound, assess it, return to the task. Notice a smell, assess it, return to the task. This kind of scanning behavior kept early humans alive by making sure nothing dangerous went unnoticed for long. In the modern world, that same vigilance system is being triggered dozens, sometimes hundreds of times an hour, not by predators, but by notifications. A 2019 review of screen time research found that the average person checks their phone somewhere between 80 and 150 times per day. Each check activates a small burst of the same reward chemistry that once reinforced genuinely useful behaviors, like finding food or reconnecting with your group. Your attention system was never built to sit still and focus on one task for 8 uninterrupted hours. It was built to scan, notice, and shift, constantly, in an environment where scanning kept you alive. Modern work culture asks your ancient scanning brain to behave like a machine built for sustained, narrow focus. It was never that machine. It was never supposed to be. Even your social brain, arguably your most sophisticated piece of evolved hardware, is running on assumptions the modern world has quietly broken. Anthropologist Robin Dunbar proposed in the 1990s that the human brain can meaningfully track roughly 150 stable social relationships, a number now commonly known as Dunbar's number. This limit is tied directly to the size of the human neocortex and appears consistently across small-scale societies throughout history. 150 people. That was the world. You knew their names, their histories, their reputations, and they knew yours. Social standing was earned in person, over years, inside a group small enough to actually track. The average active social media user today is connected to hundreds, sometimes thousands of people. Your brain is being asked to process social comparison, status, and belonging across a network many multiples larger than anything it evolved to handle. Researchers studying social media use have consistently found associations between heavy use and increased feelings of loneliness and inadequacy. Even though users are, by any technical definition, more socially connected than any humans in history, more connections, less belonging. That is not a contradiction. That is exactly what you would predict from a brain built for a village of 150, suddenly exposed to the entire world at once. None of this means modern life is a mistake, or that you are broken for struggling inside it. It means something closer to the opposite. Every uncomfortable, confusing, exhausting reaction you have to modern life is evidence that your brain is working exactly as designed. It is responding intelligently to signals, using a system built by 290,000 years of trial and error. The problem was never the machine. The problem is that the machine was handed an environment nobody consulted it about. Understanding the mismatch will not make an overdue email stop triggering your stress response. It will not make a supermarket aisle stop lighting up your reward circuitry. It will not shrink your social feedback down to 150 people. But it changes the question you're asking yourself when modern life feels harder than it should. The question was never, what is wrong with me? The question was always, what am I asking this ancient machine to do that it was never built to handle? You are carrying around one of the most sophisticated pieces of biological technology ever produced, fine-tuned across 290,000 years for a world of small groups, real threats, and rare rewards. Then you dropped it into cities, screens, and a global feed of strangers and asked it to feel at home. It never had a chance to catch up. It is still running the oldest program it knows, in the only world it was ever actually designed for, doing the very best it can with instructions written for a planet that no longer exists.